please. So looks like Sunday morning blues. Nobody wants to answer. All right. So inputs can come from different teams. Okay. Let's analyze each of the teams and how do we qualify them. Okay. So first is from your synthesis team. So synthesis team has delivered what all the inputs you will get. You will get a net list. You will get a constraints.
At least an LTC.
Yeah. So you will get net list, SDC, and you have to ask for what are the timing reports and if the formal verification is good enough. Okay. And what is the methodology used for synthesis? So this is also an important input for you to understand. Um, so and what all are the aspects of don't touch and don't use files which were used? Okay, just supposed to be used in your design. So it's very easy. Everybody says just give me the netlist SDC. That's all you think as synthesis. It's not like that. Okay. So there are several inputs which goes into synthesis, and you have to actually analyze each of them. So, so they have given you netlist. So what would you check on the netlist from synthesis team?
Is there any inconsistencies are there or not? We need to check that.
Sorry, Sridhar, your voice is not very clear. So
Um, we need to check is there any illegalness or unconstrained net is available. Is there or not? We need to check in that net list.
illegal cells are unconstrained nets.
Yes.
Unconstrained, let's come. I mean, let's talk about SDC. Just analyzing the netlist. So illegal cells. Okay, good. What else will you check on the netlist?
Legal cells and
Okay. So on the netlist, when you are getting, you have to validate the following. Okay. One, first check what is the area of the netlist, right? And then you check. So what are the kind of cells? If there are, look at the area report of the cells. Okay, you can ask for that and look at how many complex cells, stuff like that which has been used, which will tell you the difficulty in terms of your routability and congestion you are going to get. Okay, so you will have to look at the area report and you can analyze that and put that, when you look at this, say it's like 20% complex cells, so on and so forth. And you'll look at what are the number of memories, types of memories, and what are the sizes, so that if there is any floor plan problem, you can go back and look at advising what libraries need to be used. Third, what kind of variety of cells which have been used, whether it is HVT which has been used or SVT or a combination, or they have only used ULBT, which will tell you the difficulty factor in terms of cells you are going to use. So if they have used all LVT cells, for example, and they have synthesized, and that really you will only have to recover, right? So which is generally the case with the AMD, as I told you. So then you'll have to check for so they will give you params. Okay, so we will talk about what those params are, but in the netlist you can check uh, these aspects and look at if the access time, setup time and hold or clock to code delay for your memories are good enough to meet the timing. Then so you'll have to look at the size of the memory, the type of cells which have been used, the area of the cells, etc. Just at the netlist and data report. Next, from the netlist point of view, you'll have to, just as Sridhar said, okay, whether, now coming to sanity checks, okay, whether there are illegal cells. So which are illegal cells? If they have used data cells in the clock path, or clock cells, the data path, that's not illegal, but not required, because they will add to your area and stuff like that. But data cells not in the clock path, because they are not finely characterized. So you'll have to check these. Then, so you'll have to see whether all your, the next check you will do is Hunt-driven inputs, okay,
Hundred
multi-driven
inputs
inputs,
and
okay.
multi-driven
You will check, for combinational loops, right? So
unloaded output.
unloaded outputs, if they are there, and those cells, if you can actually delete, or they've been force kept, right? So you can
Correct.
actually check, whatever, why these cells are actually there, right? So you'll have to check these things in your netlist, right? So, and so that you can justify that this is the area used, and then whether your floor plan, whatever size you are going to use, whether they will fit or not, right?
Sir,
From the
actually,
netlist,
they should
you will
not
have
be.
to again understand if there are any special cells, okay, which will require you to do special types of placement. If it's quite possible they have synthesized without using isolation or certain things, and when it comes to low power, right, CLP, if they have not used isolation in some inputs, etc., outputs for it, sorry. So then you'll have to check for those kind of things in the netlist. Now, what will you look at your SDC, right? So we spoke about all the checks, like your on the netlist. Again, if your inputs are properly buffered, if they are all flopped, or they have actually combination logic, you can also verify what is the depth of logic used in your netlists. Okay, you can after that, when you read that, look at the long stuff, if your inputs are registered, etc. Now, from SDC point of view, what checks will you do? So from SDC point of view,
Sir, sorry for interrupting you.
yes.
Sir, in netlist, there should not be any black. In a design check, there should not be any black box. If it is necessary, it can be. But what is exactly black box? Black box means the spacing or blockages or
No,
end
no.
capsule,
Black
even
box is
physical.
not spacing or blockage. Black box is certain modules which has not been implemented, okay, or they have been used. For example, you have used a macro. So what is inside the macro, you don't need to know, or memory, you have only used the periphery, right? So what's inside is not of your concern, okay, or it's not used because it could be a problem. So black box, again, you verify if there are black boxes, some modules not implemented, then you can ask why. Okay, so that's a good question. You can check the number of black boxes as well. Okay.
But even the black box can be there in a netlist if it is necessary. But what is the reason like that? Means,
See,
there
in
is
the
no.
fine flat list, black boxes should not exist. You understand? So it can only exist if that module has been implemented and you are only using don't touch. For example, you are using analog and you are using that connection. So an analog is outside. So for that, for your purpose of timing interpretation, that will be treated as a black box. So there are 3 types. You can actually use black box, white box, gray box, okay, stuff like that. So what is a black box is you will not have anything other than the pins, okay, of that box, and probably a physical size. Okay, it's like 1 cross 1 mm, 1 cross something like that, and only the pins, and it will define you what is the relation between the input pin and output pin, nothing else. Okay, in a white box, everything internal to that is visible. For example, you are doing somebody is reading your block netlist at the top level. If they are reading your entire netlist, they're not using the top level library information, your .lib, you have, everybody uses library. What is inside that is again a black box. One of the reason why you will also get black boxes, for example, they have used some library which you have not incorporated in your design flow. Then they are calling for some block, some cell, but that cell does not exist in your library, or that block does not exist. Then it will report them as black boxes. Then you have not read that library, you have not read that netlist, you have not read that particular implementation which is required. Okay, then it will report that. As long as the timing relation is defined and you know that this is supposed to be a black box, because I really don't care what's inside. That's an analog block, I really don't care because I'm not going to touch it. That's when you will start using them. Okay. A gray box or whatever you want to. So these are all NL. You have different models, right? NLDM, CCS, etc. A gray box is where up to the periphery, up to the next flop, from the pin to flop, that particular logic portion is visible to you. But beyond that, beyond the flop to whatever is internal, doesn't care. So those kind of things are called gray boxes. Okay. All right. Let's go back to the question we were actually dealing. So now coming to SDC, you will verify, right, whether first when you are reading the netlist itself, okay, if like if there are instances or basically reference models are not available, right? All those issues you should be able to report. That will tell you library is not done or some stuff is not given, some netlist, some piece of netlist is missing. Okay, when you're reading, it should read clean without any errors. The other thing you have to actually look at is when the netlist is read, are there any errors in the netlist? Okay, you have to monitor your logs also, right? So when looking at that, same thing when they have given you input, ask for their log files, and you can verify what's actually happening in them. Now similarly, when you are reading the SDC, first thing, the SDC will be for as many modes as you are using. There could be many functional modes, there could be many scan modes. So do we have for every mode a separate SDC? Okay, at least the bare minimum scan shift, scan capture, okay, functional mode, right? JTAG, all these modes are there. Sometimes you will combine. So how you should ask for scan shift, where is it combined? How are you taking? They could have multi-cycle, they have actually enabled it. Then you'll have to verify. Okay, so there's a visual inspection. And first, when you are actually looking at the SDC, you ask for the clock diagram report. You correlate between the clock diagram and the SDC if all the clocks are actually defined in your SDC. Okay. Why certain clocks? So you will understand what is the functional clock and what is that they have actually given in terms of derived clocks. Okay, especially the leads are expected to do this analysis Don't just assume that every input you are getting is like a golden. Somebody has done a great job and delivering it. Then you are not doing your job. Okay. So you have to ask for the information. So this is supposed to be the clock diagram, whether there is a correlation between the clock diagram and your SDC. The clocks are defined properly. Yes. If some clocks are missing, etc., they may read fine. It will report something. Okay. Just say, set false path start or star. Right. Every timing will meet. That's not the design that you want. So you'll have to look at, screen it, and understand. So read for each mode, that particular timing, read for each mode and report for that mode whatever you are seeing. So for each mode, when you are actually reading, there should not be any SDC errors, right? The relevant clock should be defined, and you have to actually verify if there are any unconstrained endpoints for each mode, because some mode there won't be, every flop will be constrained. Some mode the flops are not constrained. You'll have to know whether that is valid, that is okay or not. So unconstrained endpoint or unclocked inputs, it's possible by design. There are certain flops in some mode which are unclocked, but you will have to have the list and verify that the designer says it's a good to go. Otherwise, don't assume. So check for unclocked endpoints. Okay. And unconstrained inputs. Okay. If there are physical design constraints set, what is the max fan out, max capacitance, or clock transition, data transition, input. So have they been set any driving cell, or have they given set input transition, right? You have to check these aspects, any unconstrained inputs or unconstrained outputs.
Hello.
So what was that, Sridhar?
Sir, actually, we will give the set max delay, right, in your LTC. How will you decide that max delay?
See, max delay will only come when you are not able to constrain a certain path. For example, there's a path between the direct input pin to the output pin. Okay.
Okay.
Now, there is no clock which is actually, it's directly from the input pin to the output pin. All right. Now, when this is there, how will you actually make sure it is optimized? You set it with reference to some clock. That clock, does not exist. There's no flop for it to constrain or anything. So then for all the direct input to output paths, you will constrain them as a max delay constraint. Set max delay. But when you generate this library, again, you will see that, the relationship with reference to that. Or you can set it to virtual clock and then, but so set max delay will only come for paths, like inputs to outputs, or there is a path for analog port, right, where you want to just put it, there's no clock reference to it. You just want to maximum constrain that particular path for some reason. So that's when you will use set max delay. Okay. So you'll have to check that, as I said, right, unconstrained endpoints, unclocked flops, right? And you'll have to actually verify from an SDC, as I already told, errors, no errors, warnings, because warnings are dangerous. Okay. So, and you are likely to miss those warnings. Document them. Document every type of warning.
Set max delay means whatever we are giving the input delay, output delay for a particular path. If you want to override that particular one, we can do the max delay, right?
No, you are giving input delay, output delay for that path. You are giving
But
input delay with
normal,
reference to some clock. See,
yes,
every
sir.
pin, if you have 10 clocks, and if there is a clock reference for every pin, for that 10 clocks also you should have a timing reference. Now, when you have a direct path between input to output, where is the
Mhm.
clock coming in? Which clock is timing them? Internally, there is no clock connection. So how
Yes.
will you constrain them?
And then with virtual clock.
You use virtual clock also. Virtual clock only when there is a flop internally, and externally you are trying to say that this path is actually clocked by this one. Okay, let us say, I can draw the diagram and tell you, but when the ideal right now, you just assume that you have to actually use a set max delay. Okay, I'll explain this in detail by when you actually draw and tell you that. Okay, because then we'll have to spend some time. I'll explain. Okay, the easiest best form is to actually add a set max delay. Okay, just by setting input delay, output delay, you won't be able to tighten that path. Okay, because again, just take this for now. Okay, I'll give you the explanation later. Okay, so I was telling you, check for unconstrained inputs, unconstrained inputs, outputs, and no physical constraint. And actually, if there are no physical constraint, highlight them. Okay, if there are no clocks in a certain mode, highlight them. In this mode, these flops are not getting these clocks. Okay, document errors, warnings, etc. Now, when you have timed the design at the floor plan, the next path is you can use a zero wire load, and you can actually report timing on a zero wire load model. Whether when you are actually reading the particular netlist and the constraint, what is your timing? Whether you have a setup violation in certain corner, you can do report QR. You can figure out for each report QR and report constraint all violators. Report QR when you are looking, then for each clock domain, it will report what is the logic levels used, whether it has a WNS is 0, blah, 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 blah. Right? So capture that statistic. Okay. And tell them, hey, there's a problem with this path. What did you do with synthesis? Why is this timing path not closed? You'll have to have that dialogue and conversation. If everything is done, yeah, this input is good. Because in AMD, there's always pressure. They will tell you have got it, just run. Unless you are actually telling your problem, I don't want to accept it. I'm already working on a previous version, which is good. This particular at least has this problem. If I take, it's unnecessarily waste of time. I'm not going to add any value. They have to fully force you before you accept. If you're not convinced that that netlist is going to yield, because somebody is telling you, you are going to be in problem. Because they say you never asked. This is a very typical way in which AMD functions. So understand, analyze, qualify. All three words are important. Okay. If you don't understand, you won't be able to analyze. Because if you have not understood whether that is right or wrong, and you do analysis, you will do wrong analysis. You may not do accurate analysis. So understand, analyze, and then you qualify. Yeah, I've analyzed whether it is acceptable or not. What are the issues you have to highlight and tell them. And at the end of therefore, yes, you have made your job, you have told your issues. Now that it has come to, they put it on the desk and you tell, okay, it's your responsibility. Yeah, fine, I will run it. then they cannot question you. Put that in the email. So, so SGC you will have to qualify, right? And timing you will have to qualify. As I said, okay, setup violation, hold violations are there. If you are saying, multiple multiple nanosecond of hold violation, why? Could be because there are some exceptions not defined. Tell them. And if there are clocks, from a clock diagram, it says they are asynchronous, but there is relationship which is shown, then some false paths are missing. So you'll have to actually qualify them. Okay. This is only at a sub-lead and lead level, this analysis to be done. For juniors, you run it for now, but important to understand that this is there, and you can put that in the record. You have to record everyone, no matter whether you are doing it for first time or 10 times, record it. Okay, and say this is what I have got. Okay. And when you are reading, the SDC might have constrained some register. That register will not exist in your netlist. Could be a problem. You can report them, right? Get that. So that's about SDC analysis. The next is, don't touch, don't use cells. Okay, they are there, and then that
Like
list is
library
there.
thing?
If they are not given, you should ask for that, which are supposed not to use, right? You have to ask that question. They can say you can use anything. You should have a record. You're not supposed to use more than 12x drive, 10x drive, because they will cause you a problem. Only when the routes are thick, you are allowed. Otherwise, it will cause you EM violation. Right? So things like that, data buffers not more than 10x, clock buffers not more than 12x, because data path you may use double width, etc. So look at this, don't touch, don't use, and verify, that we have already discussed in your netlist qualification.
Sir, these
Next
don't
is-
use, don't touch will get from synthesis team only, right?
Right?
We'll get from synthesis team only, right? Don't touch, don't use. Along with the library
Yes.
side.
Either the synthesis team will give you, or the flow team will give you, or the library
Okay,
team will give you. One of these three, because even somewhere the source will come from the library and flow team to say that these are causing you issues.
Okay.
You may have TMAC, you may have some overlay cell, you may have some special cells there. Okay, whether if overlay is there, they are constrained, they are supposed to sit there, something, and you will have to ensure that those are all present, those libraries are all right. Okay. So this is the second part of qualifying SDC. The third is you have UPF. UPF also you should ask the synthesis team. So, or your design team, and look at, okay, what is the UPF? UPF or CPF, whatever they have given. Okay, and validate what is the power intent of the design to what is actually coded in the UPF constraint, and you say that whether there are any errors. You can look at UPF report, and if there is some output pin which is not isolated, or there is no level shifter, check on that. Right? So you'll have to qualify your UPF, read them well, and then ensure that the missing cells, ask them, whether your CLP is clean. They may say CLP is not clean, but eventually we will clean it. But they will have to tell you. Then you'll have to make provision for those cells in those locations, because these will be big cells. They are supposed to sit here. Yesterday we already discussed all the low power. You can qualify. If there is only shut off, then these cells have to be there. Whether they are there or not is, you have to ask for that. Okay, because you will have to do the power connections accordingly. No. So you ask for UPF and you qualify them, and you are seeing some errors, when you have read the UPF and it says, hey, I don't understand this particular UPF command. There's no flop here, or it's not able to reports issues, report them back. If you're not able to fix, analyze, then report them back. So this is the UPF qualification. Then basically you will have to ask for what is the formal, whether the formality was clean from their end. Formality and CLP should be clean. So if formality is clean, they should say yes. If it's not there, then where the issues could be. You can also ask. Okay, so ask for that. The next question you should ask is whether the synthesis used DFT. Okay, incremental synthesis was done after reading all the DFT logic, or it was pre-DFT synthesis. What is the methodology of synthesis that they used? Whether it was DCT, DC. DCT means they have used the floor plan. Who gave you the floor plan? Somebody, either you would have given, because then there's the base floor plan. If they have said, I don't have any floor plan, I've done basically logic synthesis, or I have done DCT without actually using the floor plan, then yes, the DCT has been done, placement has happened, but the next input you have to do is you have to implement it. You have to take it through the placement. And once you are comfortable, you see some stuff, but still QR is not good, you have to give them the floor plan so that they can use that for their next iteration of synthesis. There's always an iteration. There's always a give and take between you and the synthesis person. So this is the next question, right? So understanding the flow. And log files and reports of their stuff. If they have already, their reports itself says timing violation, you can question, why are you delivering? Why this path is violating? They may say, I'm going to fix it later, or this constraint is missing. We are looking at it. We are verifying. So you'll be able to justify. So this is what was your input. This is what is your output. So this is where you are seeing some problem. Otherwise, you just run your placement. You are seeing some path violating, which is already supposed to be violating, and the tool is unnecessary working on it. Because you should know how your PNR works. It works on your WNS, etc. So if you have large WNS, this is a problem for me. I would put a false path or multi-cycle path for now, so that my runtime, my QR is not impacted. You have to understand why there is a violation. Skew or clock uncertainty, or they have used a frequency. What is the they have used? What is the derating they have used? Who will give you all these inputs? Derate. You have to ask that again from your synthesis team or your flow team. If they don't have, then you should ask your flow team, because they might already have given it to them. Even if they have given it to them, you should still go and ask your project manager and your flow team, what is the design margin which I am supposed to use for my design, for my PNR, because it could be different from what has been used for synthesis. Ask for that. whether POC, AOC, whatever, right? Use that relevant library and this one. So that's the check with regard to synthesis. Next, you can talk to your DFT team. What inputs? A DFT, have you inserted a scan flop? Hey guy, where is my scan def? Okay. And ask whether actually MBIST, they have actually inserted, callers, etc. and check for which memories are supposed to be grouped. If every memory, all the memory used in the design, they have just actually inserted one MBIST and it's causing you congestion, it's a problem. You have to go back and give the feedback. No, this is my float plan. You have inserted MBIST not in accordance with the physical aspects of the design. So then you will have to, then they will go, they'll group, like they may put insert MBIST in different format, maybe one group at the top, one group at the bottom, etc. Because DFT will connect and that may be real cause of congestion. You have to understand what you are getting is not necessarily golden. They can be changed without impacting the design aspects. So that's basically test. They'll just do their job easy. What comes, just give it to the tool, put it into a tessent, that gives you some output. You cannot take garbage. Garbage in will be garbage out. So look at that analysis and ask for that scan def, ask what is supposed to be done, what has not been done, and how the DFT clocks are supposed to get connected. Okay, ask for the DFT clock diagram as well and ensure that you are compliant with that. That's about DFT. Next, you will talk to your top level physical design engineers who is doing chip level. Here are the questions that you are going to ask them. So does he have a floor plan def for you? What are the feed throughs? Where are the repeaters? You will have to analyze, if your feed throughs, are aligning or there is crisscrossing between the feed throughs, right? What is the shape? Why the pins are in this particular metal layer or in whether it is top, left, bottom, right? If they have given you a funky shape, why is this shape? You'll have to analyze from a top level. And power, what is that? How this is connected? Whether power gators, etc. are already inserted or not. If in the synthesis they have not used that, right? And only after that you are actually going to get this, then you'll have to incorporate that and validate your timing because your area has to accommodate for that. Okay. So from a top level, your floor plan inputs like def, your power routes, your pin locations, okay, your feed throughs, Tmax cell insertion, okay, or any special cells which have been inserted, you have to understand the constraints that they have given for you for those special placements. You have to understand what are the constraints. You have to understand which metal layers you are not supposed to use, which metal layers they are using, top 2 metal layers. If they are using top 5 metal layers, you have to question them. Where are the power routes? How I'm going to do? What is that I'm going to do? So those are the aspects you are going to talk to your top level engineer. And there could be many top level people. Somebody who's only doing feed through analysis, somebody who's doing FCFP, somebody is doing, full top level floor plan, right? And again, from top level, you will have to understand timing budgets. Guys have given something in the SDC. Okay, these are where are all the, just because you have read that constraint and it is meeting timing. No, if there could be some inputs which which a budget flow is failing, then you'll have to go back and analyze, okay, these IOs are not constrained enough. The bare minimum 70% should be given to the top level when you're doing initially. You have to analyze like that 60%. Okay, they have relaxed. They have given all 100% internally, but eventually when they do FCT, they are actually getting screwed. These are these flops supposed to be closed, you know, whether magnet placement has to be used, etc. All those strategies are derived how the IOs are supposed to be constrained. You have to understand the top level. Give me the top level floor plan. You take that top level floor plan, you understand how your block is fitting into that. So if my area were to increase, you will have to understand whether you can increase at the north side or south side, east side, west side, etc. You'll have to understand where there is space, where there is no space. Provide the feedback. So that's about the top level. Next, the flow. The flow team, which versions of the flow tile builder I'm used, which are the tools versions that I have to use, what are the design parameters I'm supposed to use, right? For your implementation, you have to understand. They will give you tile.params. Okay. Check for that. And whether they have given some override files, then you understand. All these checks. The next, you will ask, hello. The next is library. So when you are reading the libraries, you have to understand, you have to analyze whether all the libraries have been used, whether there are any, you know, frame views generated or black boxes, etc. Okay, what is supposed to be hidden, as I already told you. So read the necessary library and ask which version of the library, what is the next that is going to come. So you have to talk to the library team, and if there are any unreferenced cells, etc., you have to fix them. So interaction with the library team is very important, and you do the proper analysis on that. Then comes is your project manager or your lead, and understand, you know, what is the timeline, how many licenses. See, somebody will give you, you know, tools, machines, okay, whether you have respective access, okay, to run. Why you are not able to run, whether you have been added to the respective group, right? Which group should I get permission? Initially, when you go, you won't have any permission. You have to seek permission from the respective guys, you know, and they will have to send you emails. Then take all the approvals, TSMC approvals, etc., before you are able to even run. So that is only IP approvals would have come. Yeah, you can use. Next is machine approvals. Next is, you know, the licenses which are given, you know, and then run it accordingly. So ensure the infrastructure is available. Understand the schedule. Understand what has been budgeted in terms of their PNR. 2 weeks means, you know, then what do I have to do? You have to capture the data runtime. What are the design margins I am supposed to use? All this you'll have to discuss with your lead and manager. So that's about the qualification of input. Now we will tell how to qualify each stage. I'll just take a short break. I'll again call you. Okay. Now the time is what? It's going to be 10:30 and 10:22. Yeah. Is it okay to any questions that you have?
No, sir. Once we'll go to floor plan sales, might be questions might be raised.
Yeah. How do you do a floor plan using this? How do you qualify a floor plan? Right?
Yes, sir.
We'll call you back in some time. Thank you.